My name is Luke Hoban. I work at Microsoft. I also work on the ECMAScript standards body, which does the standardization of the JavaScript language. Dave Herman is also here, although I think he just stepped out, who's also been very actively involved in a lot of the stuff that I'll be going over quickly today. So if you have questions about any of this afterwards, myself or Dave, I'm sure would be happy to talk in more depth about it. Just a first quick look at kind of the history to put ECMAScript 6 in some perspective. So the JavaScript language was first standardized in 1997 and was obviously implemented in many browsers through the late 90s. And one of the interesting things to note about the early history is that there was a very quick standardization through ECMAScript 1, 2, and 3. And each of those actually introduced meaningful new capabilities into the JavaScript language. So JavaScript as it looked in sort of 96 and JavaScript as it looked in 99 were actually quite different languages. The next 10 years, there was some work on ECMAScript 4 throughout the mid-2000s that was ultimately abandoned. And this was a fairly ambitious set of work on really changing the character of the JavaScript language in a meaningful way. That by the time it got to sort of where this endpoint is, around 2007, there was a realization that that had sort of stepped to a place where the web wasn't at that point. Ajax was happening, a bunch of things were changing around the web, and where ECMAScript 4 wasn't quite in the right place with that. So that effort was abandoned and a more incremental approach was taken instead. And that incremental approach ended up being ECMAScript 5 in 2009. Which is what effectively is implemented across all major browsers and JavaScript runtimes today. One of the interesting implications of that was that between 99 and 2009, there were no changes in the JavaScript language. And so more than most languages which are used as heavily as JavaScript is, JavaScript has felt like a very fixed quantity for a long period of time. For a period of 10 years, there was no change. Java has changed in that time frame. C++ has changed in that time frame. C# has changed quite a lot in that time frame. But JavaScript really was a fairly fixed thing. And it was only in 2009, at the end of 2009, that ECMAScript 5 started to show some changes. And even the changes that were in ECMAScript 5 are, most of them are not super visible changes. There's very little syntax change in ECMAScript 5. There's some library additions which are quite handy, but they're not the kind of things which radically change the feel of the language in a meaningful way. ECMAScript 6, on the other hand, is where we'll see more changes, and that's what's being worked on now. Some of the capabilities of ECMAScript 6 are already showing up in browsers today, and standardization is nearing a close. So three sort of key characteristics of ECMAScript 6. First, it's a much more significant set of changes than ECMAScript 5. So there's a lot of changes across many parts of the language. Is a lot of new syntax. So whereas ECMAScript 5 had effectively no new syntax, actually, does anyone other than Dave know what the only piece of new syntax was in ECMAScript 5? So ECMAScript 5 had a notion of accessor properties, which was the only place where there was any new syntax in the language. But even that's not used that heavily compared to most other parts of the language. So for most developers, ECMAScript 5 effectively had no syntax. ECMAScript 6, as we'll see, has quite a lot of new syntax sugar. Another key point has been the backwards compatibility bar. So I think early on there was a decision point about whether or not ECMAScript 6, given that it was going to have a number of changes and additions in it, whether it would be backwards compatible or whether it would require an intentional opt-in. Like instead of using an existing script tag, you might have to use a new kind of script tag to opt into this variant of JavaScript. The decision was that it was going to be a backwards compatible set of additions, so that puts a lot of constraints on the design space, obviously, but I think is a very good thing in terms of how we'll naturally evolve into using ECMAScript 6 over the next several years. Just a couple of notes. There's spec drafts available, so everything I'm talking about here is sort of fully available in those spec drafts. The final spec, I think, was hoping to be around July of this year. That's probably going to be a little bit later, just some final things getting locked down. And the hope is to ratify this at the end of the year, and that also may slip a little bit, but is basically where we're aiming for. Okay, so the rest of the time I'm going to spend doing a broad but very shallow look at effectively all of the new features of of ECMAScript 6 to give you a sense of just where the things are that might be interesting to your particular perspective on the language, and then afterwards you can drill down on them in more detail. So the first few things here will be some sort of syntax sugar. First one is arrows. So we talked a lot about arrows earlier today in the Java talk, and saw something like some arrow syntax in C++. So JavaScript has had first-class functions, obviously, as a core component for forever. The arrows are effectively for JavaScript just a shorthand. So using the anonymous function syntax in JavaScript is somewhat heavyweight, considering how frequently they're used. So now, with arrows, you have the ability to write just a simple shorthand like v arrow v+1. You can leave off the parentheses if there's just a single entry. If there's multiple parameters, you can have parentheses. These arrows can have either expression bodies, like in the top, or block bodies, like in the second one. And the one particularly notable thing, like all of that above, is the same as if you've used C#'s arrows, or I believe both of those are true for the Java arrows as well. The one particularly notable thing for JavaScript is that the arrows in ECMAScript 6 have this notion of lexical this. So one of the big gotchas that has sort of plagued JavaScript for a long time has been the dynamic binding of this. So whenever you have a function, the this that you're going to get when that function is invoked depends on the way in which the function was called. And so that means that if you have a callback function that's used within something that you kind of intend to be a method, then this inside the callback function will not be the same as this inside the method in general. Now with arrows, it is going to be the same. So this inside an arrow is always the lexical this that's in scope. It's never a dynamically invoked thing. And this basically just means that in general, the basic answer is going to be if you're using callbacks, write arrows. If you're using methods, something like a method, continue to use function syntax. So arrows is just a nice, simple shorthand. The second piece of sugar is classes. And this one I think sometimes gets, people look at it funny when you say that classes are sugar. But in ECMAScript 6, the approach to introducing classes in the language is very much to treat it as just a simple piece of sugar over the very common sort of class patterns that are used with the prototype mechanism that's available in JavaScript. So in this example here, you have a simple class. A few things to note. The class can have a base class, so you can have an extends clause there. That extends clause is just an arbitrary expression which has to evaluate to an object, and that will get used to chain the prototype hierarchy. The constructor, so there's a special named sort of effectively method here called constructor. And if you have that method, that is that will define the body of what happens when you say new skinned mesh later on. It can make supercalls, so you can either make supercalls inside the constructor to call up the constructor chain, or you can see within methods you can make supercalls in the method hierarchy. There is no, so there are methods. So here we have an update method, and there are static methods. So I can have a static default matrix method here. There are no field declarations. So JavaScript is obviously dynamic, and so we can just say, inside the constructor, we can just initialize the state onto our class instance. So there's a few sort of simple pieces of sugar that apply to object literals. The first one down here is obviously methods. So instead of saying toString colon function open paren close paren, I can leave off the colon function, which just makes it a little bit shorter. There's a shorthand for assigning a property to the same named variable in the scope. So if I just say handler comma, that's the same as handler colon handler comma. And the last one is underscore proto. So that's a feature that was in many JavaScript implementations that allowed me to set the prototype of my object at object instantiation time. But it had not been in IE until IE 11, and had not been part of the ECMAScript standard at all. And so we've introduced it now into the standard, and IE has implemented it. And so now there's a consistent way of you initializing the prototype. And the last one is that super, which is available in classes, is also available inside object literal methods. Okay, so another piece of, so I call this sugar. This one's maybe slightly getting outside of being just syntactic sugar, but there's already two forms of string literals in JavaScript, but we're adding a third. So the third is effectively template strings. So this uses backticks as the string delimiters. So with template strings, you can just write a lot of kind of raw things. So one of the basic things is multi-line strings. There was no multi-line string construct in JavaScript previously, and so with backticks, you can just put new lines or whatever you need inside your string literals. But the more interesting thing is the string interpolation feature. So you can write something like this, dollar curly braces to escape into a place where you can have an arbitrary JavaScript expression, and that will evaluate in the lexical scope. So this will interpolate in the lexical value of name and of time. Time today. So this is very handy. This is available in a lot of other languages. The one sort of more interesting thing, I don't know of any other languages that have this feature, is this notion of having a tagged template string. And what the tagged template string does is lets user-defined code participate in the way that the template string gets created. So in this case here, it just gets created by concatenating, right? We concatenate this string plus the value of that plus this string plus the value of that. In the case down here, the get there is some value in lexical scope. So we look up get in the lexical scope and we get back a function. And that function is expected to take a series of values. So the first value is going to be the sort of first chunk of literal string. The second value is going to be the value of the a variable, and so on. One value that's a literal, one value that's a dynamic value, all the way through till the end of the string literal here. And then it gets to return whatever it wants. So it can put together that string and either it can change the way in which it constructs the string. So for instance, in this particular case here, it could do the URL encoding and the HTTP encoding as needed for the particular places in the HTTP grammar where there's values being inserted here. But it could also return back a different value. So instead of returning back a string, it could return back a function which is able to fire off a HTTP request and take as a callback on ready state change handler. And so this lets you sort of use string literals to embed little systems that can describe various domains. So interesting things you can do on top of template strings. Okay, some sort of simpler things. So destructuring is just a very handy way of you taking a value and pulling out pieces of it to variables in lexical scope. So for instance, you can do destructure lists. So here you can take A is going to be now assigned to the value 1, and B is going to be assigned to the value 3. You can also destructure objects. So in this case, you might get back some AST structure, may have all kinds of different data in it. But we want to just pull out the op part of it, and the op of the left-hand side part of it, and the right-hand side of it. And so in this case, then I will have values bound to A, B, and C in my lexical scope that are pulled out of that data structure. One of the interesting things that was, there was some back and forth. Yeah, this question.
What happens if one of those patterns fails?
Right. Yeah, that was actually exactly what I was going to say. Because so one of the big questions that we've had, and this was sort of went back and forth on. I think there's some people who still can think that we're going back and forth on it. But it's the design decision that we've ended up with is that it's effectively the same as what you would do if you did the dotting yourself, right? So if you said temp equals getAST node, and then you said A equals temp.op, B equals temp.lhs.op, etc. And so that's a pretty, like we've talked about as being sloppy, right? In JavaScript, you can get away with a lot of that without any, you can do a lookup on something, which is if it doesn't have a op property, it'll succeed and just give you back A being undefined. Now, if getAST node doesn't have an LHS property, then the first lookup will be undefined, and the second one will throw the lookup of the op property on that. And so this certainly can throw, but it throws in exactly the way that your code would have had you written this out in the way you would have before. And that's generally a pattern when we've introduced features like this that become shorthand for patterns that people would have been writing in JavaScript before. It's generally been the case that we've kept the same semantics that they would have had from the way that they would have written that before, instead of coming up with instead of trying to make the language slightly different or slightly more sort of robust in those areas, because it reduces the amount of extra sort of overhead there is in understanding the features. But anyway, yeah. And the last piece to note is that this can be used in effectively any place where there is a variable that can be introduced, or any declaration location. So in this case, G will automatically destructure its argument. So if I call G with an object that has a name property, then it will just bind X inside its body to the name property of that object. And this applies to all kinds of other declaration locations. Okay, so default rest and spread. So these are a bunch of sort of conveniences for how what we can do in argument lists. So for the first one, defaults, we can say that a function has a default value for one of its parameters. So in this case, y, if it's not passed, will just be assigned the value 12. It not being passed, again, there was some debate about what exactly that should mean. To be consistent with the patterns that the JavaScript developers are used to, that means either not passed or undefined. Because in JavaScript, if you just leave it off, if you provide a subset of the parameters, the remaining parameters will just automatically be passed as undefined effectively. And so this means if I call f of 3 like that, then I'll get back, what is that, 15? And similarly, if I call f of 3 comma undefined, I'll also get back 15. The second one here, we have rest parameters. So this means that I'll package up all the remaining arguments that were passed into the function and create an actual JavaScript array and pass that in as the value for y. So this allows me to capture sort of a varargs style thing. Those who have worked with JavaScript probably know that there's an arguments object today, which gives every function has access to the full list of its arguments. There's a couple of problems with that. One, it's the full list of arguments, which is almost always not what you want. You normally want just the sort of the rest of them past some certain point, and so you have to do some manipulation on that to get the part that you really want. And the other problem is that the arguments object is not a real array. It's sort of a different kind of construct, and also tries to stay up to date with your actual argument list. And so it has some weird behavior in it that really de-optimizes a lot of runtimes. So this is just a plain old array and gives you what most developers are looking for in these cases. There's a feature which is kind of the opposite of that, which is the spread operator. So in a argument position, I can take an array and use the spread ... to expand that out as though it was a set of discrete arguments. So this will effectively call f of 1, 2, 3. So x will be 1, y will be 2, z will be 3. And so these are sort of morally the opposite of one another. Okay, so that was some sugar constructs. The next set are sort of some library things. So this one's just a pure library feature, sets, maps, and weak maps. So somewhat amazingly, JavaScript has never had effectively had any data structures, right? It had objects, and it had, well, effectively had objects. Arrays have some slight semantic differences from normal objects, but effectively it had arrays and objects. So with ECMAScript 6, there's been the introduction of sets, maps, and weak maps. These are not anything unexpected in the case of sets and maps. They're just, you can see the code there. The one maybe more notable one is weak maps. So weak maps gives you the ability to effectively, the main use case for weak maps is effectively like a side table. So I want to associate some additional state with a set of objects. So I want to do something like I'm going to create a weak map, and then I'm going to I'm going to put in as the key some certain object. So here it's the object which is the setup there, and I'm going to associate some additional data with that. But I want that data to only live as long as the object lives, and I don't want this map to actually, this weak map, to keep this key object alive any longer than it was going to live otherwise.
You mean W in
I do mean W. Yes, very good. Yes. So those last two lines should be WM, not M. That definitely is wrong. But yes, so in this case, I want to basically have a strong reference from the key to the value, but weak references from the outside world into both the key and the value. So the lifetime of the value in this data structure is at least as long as the key, but that neither one of them is being held strongly alive by the data structure. And so this is something like, those of you C#, I think there's a conditional weak table or something like that. So other systems have constructs like this, but it is a very handy data structure, especially for sort of attaching state to things on the side. This can be used for sort of attaching private data to objects or something like that. Okay, next one is proxies. So proxies, one of the interesting things in JavaScript is that there's effectively kind of two pieces to the specification for JavaScript, for ECMAScript. One is the sort of the language that developers get to program against, and the syntax and the semantics of that language. And the other one is the runtime system that it's being executed on. And the runtime system has actually got a decent amount of additional richness beyond what developers can directly interact with through the JavaScript language itself. And so when JavaScript is hosted in some host environment like the browser can actually inject objects into the system which take advantage of that more rich set of runtime capabilities that are available. And so that means that there's certain browser objects or other host objects, like if you're working in a node environment or something like that, there are objects you can work with which have behaviors which you couldn't possibly implement as an end user. The language doesn't give you the tools to implement those. And with proxies, I believe that gap is entirely eliminated. I'm not sure if that's 100% true, but it's very close to true that you can now represent everything that the runtime semantics of the language are capable of describing. And you can do that basically by providing an object, like a handler here, which has the hooks for all the different sort of calls that happen inside the runtime system of the JavaScript runtime. So you can intercept the getOwnProperty descriptor call, and that's a sort of a low-level runtime operation that happens. And you can say, whenever that operation happens on my object, I want this handler to be called, and it's going to intercept that and get a chance to do whatever it wants to as a result of that. And this, there's quite a few of these. I only have like 6 of them mentioned here. I think there's something like 17 of these functions in this API here, but they're basically the exact things that map to the underlying runtime operations that can happen on an object. And once you define on one of these handlers, now I can take an object and I can create a proxy for that object. So I can create a proxy that has that object as its backing store, but intercepts all the calls and passes them through this handler to get a chance to change what those calls do before it goes and delegates to the underlying object. And so this has quite a few interesting uses. One is obviously to implement these kind of exotic objects that have behaviors that you wouldn't have been able to implement otherwise. But there's also things you can do, like I guess I have a list of them up there. You can inject logging, so you can just say I want to log all the places where someone makes a call on this object. I want to do some sort of interception of some certain set of calls. Okay. That's quick proxies. Is there a question? No. So the next one here is symbols. So in JavaScript today, so the core concept in the language is objects, and objects have to be they're a bag of string-keyed hash table, effectively. And with ECMAScript 6, instead of having just strings as keys to the properties in an object, you can also now have symbols. And symbols are equated by reference. So the only way to look up that key into an object is to actually have a handle to the same symbol that was used to put the value in there. So unlike strings as keys, where I can, if you use the string foo, I can just create the string foo over here and use that to look up your variable. If you create a symbol with the symbol constructor there, and you use that to put a property on an object, I can only look up that property if I have access to that symbol that you created. And so, for instance, here you can do things like I'm going to create a symbol inside this function here, inside this sort of lexical scope. And I'm going to create a class here which uses that key as the property that it's going to use to store the data. And so it's going to put the private data in the key, and then on the prototype, it's going to reference that in this method. So now if I create one of these from outside, I can make calls, and it will use that internal key. But from outside, I can't accidentally call, use that same name.
That function declaration is being lifted up out of the scope, so it can't be seen from outside, right?
This one here?
Were you saying function my class?
No, because this is a function block. So. Oh, I see what you're saying. Yeah. Sorry. You'd have to return this out. You're right. This example is not exactly right because you'd have to return that myClass function out of the block. But the key is you could return that myClass function out of the block, but you don't have to return the key out of the block, right? So you can still have this hidden by lexical capture. Yeah.
So what happens if you're accessing properties via the properties interface? Get all my properties.
Yes. Great. So I think that's this note down in the bottom in a sense. So there was originally actually two notions of symbols that were part of the ECMAScript 6 design discussion. So one was private names, one was unique names. Private names, effectively the difference was the difference in the answer to this question. Were they something with when you reflected over an object, when you walked over, JavaScript has a lot of reflective capabilities. When you walked over all the properties of an object, do you see the names that are on it? So the only one that's part of ECMAScript 6, which is symbols, is the unique name. So they are not private from a reflection perspective. So if I do reflect over an object, I can see them. The notion of private names was something that was considered as well, but has some challenges around what it means to do sort of anything where you do object cloning or when you do proxying, or there's a number of places where if you really want to hide these things from reflective mechanisms, then there's lots of places in the language where sort of you need reflective mechanisms to even do the core things like proxies. And so we don't know exactly what the right model is for private names today. Unique names, though, are very useful because if the problems that happen in practice around property names in JavaScript are often when people are doing things where they're monkey patching prototypes, or they're putting things onto additional, they're inheriting from some object and adding some new methods. And the problem is mostly about unintentional conflict. It's about where when you're versioning, like let's say we as the ECMAScript committee are adding a new method to array.prototype, right? Well, some other library out there in the world may have gone and slapped something on there, and so it would be unsafe to version it in that way. With symbols, many of those kinds of versioning are much safer if you used a symbol, because you can be sure that no one used that same symbol. There can't be accidental clash. They would have had to intentionally gone and reached in and grabbed your symbol and tried to reuse it for some other purpose. So it makes it so that a lot of the places where there was sort of name conflicts go from happening accidentally to only happening intentionally. So it's not a strict privacy mechanism, but it does avoid a lot of the accidental conflicts. Yeah.
What does adding the string do to the symbol creation?
Great point. Yeah, so the symbol constructor takes an optional string parameter, and that string parameter has nothing to do with the identity. That was sort of the key point down here, is that string key is not the identity of the thing. It's a debugging aid, effectively. So it's there so that in a debugger you could say this isn't just a symbol, which would be very hard to understand what that symbol was in your system. But a debugger could tell you this is a symbol, which is the key symbol. And so if you create two symbols with the string key, they're two separate identities, but they would be both shown in the debugger under that name. OK, so this one gets a little bit more interesting. So subclassable built-ins. So in JavaScript today, when you new up an object, it effectively allocates a new instance and then calls the constructor function, invokes the constructor on that new instance. With subclassable built-ins, one of the things we wanted to do was allow you to actually subclass some of the things that today you can't successfully subclass in the language. So for instance, arrays. Because arrays have some special behavior that is associated with them, you can't subclass one of them because it needs to, your subclass needs to know that it should allocate an actual JavaScript array as the ultimate thing it allocates, instead of allocating one of your subclass. So if I tried to do this today, and I newed up my array, it would give me back a normal JavaScript object. It wouldn't give me back a special JavaScript array object. So what we've done to enable this to work generally is to actually augment what it means to new an object. So instead of just invoking the constructor on a freshly created instance, we're actually first going to call this add@create. So this is the language the spec uses, but the syntax that actually gets used in text is to have a property on your object, static property, which is the symbol.create name. So this is actually using that symbol feature we just saw. And if I have that symbol.create property on my object, so in this case the array object itself has a symbol.create, then when I call new, to allocate the actual object to use, it's going to call myArray.add@create, which is going to actually go up the static side inheritance hierarchy and call ultimately arrays symbol.create, which is going to allocate a special kind of array object with all the special behaviors that arrays have in JavaScript. And then that's going to go back down, and now we're going to actually invoke the constructors. And so now we'll invoke the constructor here and do anything special that I want to do in my constructor. And so this has actually introduced sort of a two-phase construction approach into JavaScript's behavior for new. And so this is actually, it's somewhat notable that it was possible to do this in a non-breaking way in JavaScript. But it also is an interesting sort of additional hook that's been introduced. And this is also quite useful because there's work also going on now in the HTML and DOM side on being able to sort of do subclassable DOM elements, so creating your own kind of components, your own kind of DOM elements. And this also provides a mechanism by which we'll be able to ultimately create new kinds of elements from within JavaScript, since those also have to be specially allocated things that the browser environment allocates for you. Okay, one nice one probably for folks in this room are more interested generally is tail calls. You got a simple example like this, which is tail recursive. Factorial is obviously only called in tail position there. And if you do this on pretty much every JavaScript runtime today, this is going to overflow your stack. With ECMAScript 6, the spec will require that this not grow in an unbounded fashion, so that this kind of programming should be safe. This is useful both for end users, for it means you can write recursive code that's sort of safe against very large inputs. But also probably more importantly, it means that for languages which want to compile down to JavaScript, but that do depend on tail call optimizations, they don't have to do weird tricks like building their own trampolining or something like that into their runtime system. So this is a nice thing for that. Okay, just a few more here. So JavaScript has had var as its declaration construct for standard variables. Var has had this sort of odd behavior of not being block scoped. So if I have a block and I have a var on the outside and var on the inside, they're actually the same variable. They aren't hidden by blocks. And so let and const are new binding constructs which are block scoped. So if I have a const x inside this block, it is a different slot than the let x on the outside. The difference between let and const is const obviously is single assignment. So if I try to assign to x here, it's going to be an error because because I've already initialized it at the previous site. Yeah, and that's effectively it. So I think there's some shirts that some folks have that say let is the new var. That is the claim that we'll have a lot of folks using let. The next one here is iteration. So JavaScript has a for-in loop, which does iteration over objects. But the for-in loop does sort of a reflective iteration over objects. It actually iterates the keys of an object, not the values, which for arrays, which is one of the most common things you want to iterate, is not what you want to do, right? You don't want to get back 0, 1, 2, 3, 4 when you iterate an array. You want to get back A, B, C, D, or whatever the elements are. And so with ECMAScript 6, a new kind of for loop, the for of loop, is being added, which does iteration, but actually sort of custom iteration. So it does iteration over an iteration contract. And so in this case, we have a Fibonacci object, which is up here, and it has a special named property on it called iterator. And that iterator is a function which I can call, and which, when I call it, it returns a function with a next on it. So this next is something I can call over and over again to give me back the next values. And each time I call it, it'll give me both done, whether or not I'm done, and a value. And I'll keep calling that until I complete, and then we'll come out. So this is basically a standard iteration construct that's available. The sort of interface for that you can see is sort of over here on the left. But this is the foundation for having a sort of built-in iteration mechanism in the language. Okay. So iteration is very handy, but if I had to hand roll whenever I wanted to do any sort of programming over iterators, if I had to hand roll this kind of stuff, it would get a little hairy. So ECMAScript also has a notion of generators. And generators are a language construct which introduces function star instead of just function. And inside of function star, I can use the yield keyword. And so in this case, I can use a function star and then write a little infinite loop here, which every time I go through the loop, it yields out the next value of the sequence. So this is something that a number of languages, including C#, have features very similar to this. But this is basically the ability to create custom iterations. There's a few notable things about this that this example doesn't capture. One is that yield is actually more general than there's this iteration example. So yield can return a value as well. So if you looked on the previous slide, I'll just go back here. If you looked at the, where is it here? Yeah, the iterator contract is something which has a next function which takes no arguments and returns one of these iterator results. If I come to the next one, a generator extends iterator. So it implements that contract, so it can be used for of, anything like that. But it's actually slightly more general. So it can take as a parameter, as an optional parameter, a value. And if I pass in a value, that will actually be the return value from the yield within here. So it allows me to sort of continue the operation going with a value. And it also has a throw. So instead of continuing this execution going with a normal result, I can instead inject a throw in there, which effectively means this yield behaves as though it was a function call which had thrown to the execution of that function. So this allows you to do sort of a general kind of coroutine mechanism in a somewhat limited way, but with general flow of values back and forth between the caller and this guy. And that general mechanism can be used, for instance, to enable sort of async programming constructs like what C# has done with its async feature. So comprehensions. So built on top of that iteration mechanism, there's a notion of comprehensions, which is just basically a syntax sugar for combining together for, if, and return values. For folks who've seen C#'s link feature, for example, this is similar, but not quite as many different constructs in there. But I can have any number of fors, some ifs, and then return value. So this allows me to do some basic comprehensions over arrays. And there's two forms of these. One is the ability to realize the result of the iteration as an array. The other one is the ability to realize the result of the iteration as a generator, which doesn't necessarily force all the values to be created. So Unicode is always fun. JavaScript has traditionally had 16-bit code units as its fundamental building block of its strings. And so that means that when you want to use full Unicode characters, if you write something like this first line, you write that single character and you ask for its length, you get back 2, because it's actually 2 16-bit code units in JavaScript. But for a lot of code that wants to be really robust against sort of globalized inputs, we want to be able to actually write code against strings as though we are writing code against the full 21-bit Unicode code points. And so one of the question marks was, if we want to do this and be robust to full Unicode, should that be that we make some sort of breaking change or some opt-in to a very different semantics for strings? Or should it be that we layer on top a set of APIs which allow you to look at the strings in this alternate way, but we don't change the meaning of any of the existing ones? And we effectively went with the second one. So that means that the length of this string is still always going to be 2, but there's a few sort of things you can do that let you look at these strings in a way that is going to be going to see them as though it's only one character. So for example, if you pass the U flag to a regexp, then dot, for instance, which matches a single character, will now match a single 21-bit code point instead of a pair of units. So this has the maybe odd behavior of saying that I'm going to match a single character, but it's going to be of length 2, right? But that's what you expect in this case. And there's also a new form of a Unicode literal that lets you address the full 21-bit space. So I can say /u and then put in curlies. And that lets me provide a 21-bit literal there, which is obviously the equivalent of me chaining together the appropriate code points. And then I can index into an array with code point at and ask, what is the 21-bit code point at this location, which lets me go and sort of extract out the values in there as 21-bit values. And since we also are introducing iterators, we can decide what the iteration behavior should be for strings. And what we decided was the iteration behavior was going to be to iterate the code point. So here we get back only one value in the iteration, which is going to be that length 2 string. OK. Mad says I'm out of time. I know. I started. Mad says I'm out of time. I'm going to try to do modules in 5 seconds. So that'll be fun. I won't even go through the slides, but I'll just say a couple words about them. So modules are sort of probably one of the most significant pieces of what's being added to JavaScript. And they're sort of the highest level piece. Most of what the rest of it we've shown has been sort of individual features you're going to use during development. But modules is sort of how you stitch together all the stuff you're doing at a sort of macro scale. And modules provide the ability to, inside files, describe a set of imports and exports from a file, and then those get chained together. The key thing about them is that they are designed to be as close to as possible to the things which have been used in practice in JavaScript today, which is AMD in the browser world and the CommonJS node system that's used in Node.js. And so there's a lot of stuff that's been pulled out of those systems. The potentially interesting thing is that there's a set of syntax for how you write modules. There's also an underlying loader. So there's the sort of runtime system of how module names get resolved, how modules get loaded into memory, about the environment in which modules execute, is all something which you have access to sort of dynamically. And so there's a module loader system, so like system.import there, which lets you dynamically interrogate and operate on the module loading system. So you can take a look at this stuff afterwards if you'd like. So there's a few other things in ECMAScript 6 that I didn't get a chance to touch on. You can see them there. But basically, there's a fairly broad set of things there. And of course, it wasn't enough that we're doing all that. There's already work going on some things for ECMAScript 7. And we're hoping that ECMAScript 7 won't take an additional 5 to 10 years to complete. But there's a few other things that are sort of being actively worked on right now. And are likely to be available in some form or another in the fairly near future. So that's it. I think I'm out of time, so I'll probably take questions later. If you want more details on any of this, there's a list of all these features with some of the same examples right there. Thank you.
Thanks.